Here this question is asking, an amplifier has a DC gain of 10 to the power of 4 and poles at 10 to the power of 5 Hz, 3.16 times 10 to the power of 5 Hz, and 10 to the power of 6 Hz. Find the value of beta and the corresponding closed loop gain for which a phase margin of 45 degree is obtained. Okay, so here they're asking us to find out the beta value and also the closed loop gain value. And yeah, these are the two things we had to find out, and they have given which the phase margin is 45 degree. Okay, now let's see how to do that. First of all, if you want to find out beta, we had to know one relation, that this closed loop gain time or we can say eta AJF times the beta should be equal to 1, and this A value can be calculated using this formula, which is AJF, that is nothing but the A naught is nothing but the DC gain, that one divided by 1 plus JF divided by the pole frequencies. Here we have three pole frequencies: 10 to the power of 5 Hz, 10 to the power 3.16 times 10 to the power of 5 Hz, and 10 to the power of 6 Hz. So we can say the first one as FP1, and then that one times 1 plus JF FP2, and then that one multiplied by 1 plus JF over FP3. Now this FP1, FP2, FP3 are nothing but 10 to the power of 5, 3.16 times 10 to the power of 5, and 10 to the power of 6. This A naught value is nothing but 10 to the power of 4. So we can just plug it in and see what we can get from this. So here this is 10 to the power of 4 divided by 1 plus JF over the first pole frequency, which is 10 to the power of 5 Hz. And the next one is 1 plus J over the next pole frequency, which is 3.16 times 10 to the power of 5 Hz. And the third one is 1 plus JF over 10 to the power of 6 Hz. Okay, so we have all these things, but here one problem is that in order to find out beta, that's why we need to find out A first, then only we can find the beta. But in order to find A, we need to know what is this F values. We don't have it readily available, so we have to find that one. To find that one, what we can do is we can use this phase margin 45 degree provided to us, because this phase margin help us to find out the angle. This phase margin is nothing but 180 degree minus theta, and from this one we can find out the theta angle, which is 180 degree minus phase margin, and they have provided phase margin to be 45 degree. So if you find out theta, the theta value will be 135 degree. Now once you have the theta, there's a relation between theta and the pole frequencies, that is theta is equal to negative tan inverse f over the first pole frequency, which is 10 to the power of 5, plus tan inverse f over the second pole frequency, which is 3.16 times 10 to the power of 5, plus tan inverse f over the third pole frequency, which is 10 to the power of 6. Okay, and theta value we know that is 135 degree. So we can say 135 degree is equal to this negative tan inverse f over 10 to the power of 5 plus tan inverse f over 3.16 times 10 to the power of 5 plus tan inverse f over 10 to the power of 6. Okay, so this is what we get. Now we can the next thing what we can do is we can bring this negative to the other side and make this one negative. If we do that, then this will become negative 135 degree is equal to this whole thing, that is tan inverse f over 10 to the power 5 plus tan inverse f over 3.16 times 10 to the power 5 plus tan inverse f over 10 to the power 6. And here what we can do is we can use a trig identity. There's a trig identity, trigonometric identity, which says that when you have a tan inverse value, in this case let's say tan inverse A and a tan inverse B, you can express that one as tan inverse A plus B over 1 minus AB. Okay, so you can do the same thing for this one, but you have to just select two at a time. So if I take this first one and second one, I can express this one as I take the tan inverse common, and then A times B, in this case A is f over 10 to the power 5, and then B is this f over 3.16 times 10 to the power 5 over 1 minus A times B, which is f over 10 to the power 5 times f over 3.16 10 to the power 5. Okay, and the other value we just keep it untouched, that is tan inverse f over 10 to the power 6. Okay, and that one is equal to the negative 135 degree. Okay, so this is it. And then the next thing what we can do is we can multiply these terms and bring it one thing. So if you multiply this 10 to the power of 5 and this one, the power will become 10 to the power of 6. And okay, so here you have to just multiply and simplify. In that way, the expression becomes something like this. Let's write it in the next page. So when you multiply and simplify, the expression become like this: tan inverse 4.16 times 10 to the power of 5 f over 3.16 times 10 to the power of 10 f square plus f over 10 to the power of 6 divided by 1 minus 4.16 times 10 to the power of 5 over 3.16 times 10 to the power of 10 to the power of 10, and this is minus f square right here. So minus f square, here also minus f square, and times f over 10 to the power of 6, and that is equal to negative 135 degree. And this this tan inverse, if you bring it to the other side, that's tan negative 135 degree is 1. So you can also get rid of the next step, you can get rid of this tan inverse, and you can take tan negative 135, which is equal to 1. And finally from this one you can solve for the f, and if you solve for the f, you will end up getting f to be 316.122 hertz. Now once you have the f value, you can plug it in this equation right here and find out the a value, because we are trying to find a, because we know that a times beta is equal to 1, we are trying to find beta. That's why we are interested in finding a. So whatever the value a you get, you multiply that one by the beta and equal to 1, then you find the beta value. So I copy this whole thing again and bring it to the next page. Okay, so here now I'm bringing the same equation we had before. Now we know the f value to be this value 316122. So we are just plugging in this equation. So 10 to the power of 4 over 1 plus j times 316122 divided by 10 to the power of 5 times 1 plus j times 316222 over 3.16 times 10 to the power of 5 times 1 plus j times 31622 divided by 10 to the power of 6. And from this one you solve for this. Okay, so this is this thing, and if you okay, this is this, and if you multiply this one with beta, that is equal to 1. This is a value, and if you multiply this one with beta, that is equal to 1. Okay, so from this one you have to just solve for the beta. So if you rearrange and solve for the beta from this, beta is equal to, you will end up getting beta is equal to 4 point, and also in order to get rid of this j value, you have to square and square root. So let's express that one as well before we find out the beta. So to get rid of the j value, what we do is we put 10 to the power of 4 beta on top, and in the denominator we square and square root all of them. So if you do that, then the first term will become before you square root, we can simplify and bring the simplest form of this. So here if you divide this 316122 by 10 to the power of 5 j, you will end up getting this one 1 plus j 3.16122 for the first term, and then second term is 1 plus j 1.000386 for the second term, and the third term will be, and for this one the square root is not necessary. Okay, so first you simplify this one, that is 1 plus j 0.316122. Okay, these are the values you will get once you simplify this one. Okay, the whole thing is equal to 1, and then you find the absolute value of this. To find the absolute value, you have to square root and square. So this is 10 to the power of a beta, and then in the denominator when you square root and square all the values, so here you will have 1 plus, now when you square and square root, this j term will be gone away, so this is going to be just 1 plus 3.16122 square, and we are only squaring this j term right here. Okay, let's put this square root separately so we don't get confused. We are only squaring this term, 1 remains the same. Okay, then this one multiplied by square root of 1 plus times 1.000386 square. and then that one multiplied by square root of 1 plus 0.36316 whole square, and this is the whole thing is equal to 1. You solve for the beta from this, you are getting beta to be 4.9186 times 10 to the power of minus 4. Okay, so that's one of the question. That is, the question is asking us to find out what's the value of beta. We just calculated it, and then they're asking for the closed loop gain as well. Now to find out the closed loop gain, you have to use this equation. Closed loop gain is given by AFJF, which is equal to AJF divided by 1 plus AJF times beta. This AJF is nothing but the DC gain that is provided in the question, 10 to the power of 4. So we put 10 to the power of 4 for this, 1 plus 10 to the power of 4, and the beta where to be calculated is 4.9186 times 10 to the power of minus 4. 4.9186 times 10 to the power of minus 4. Is that it? Yes. So from this one you calculate this closed loop gain, and this one comes out to be 1.69 times 10 to the power of 3. And that is it. I hope you guys found this video helpful. Thanks for watching. Don't forget to subscribe my channel. See you guys on my next video.